Download this code from codegive.com, link in the description below. Checking vulnerable code, a deep dive with examples. Security vulnerabilities in code are like cracks in a building's foundation. They can be exploited by attackers to compromise systems, steal data, or disrupt services. Proactively identifying and mitigating these vulnerabilities is crucial for maintaining a secure and reliable application. This tutorial will guide you through the process of checking for vulnerable code, covering common vulnerabilities, methods of detection, and practical examples. Understanding code vulnerabilities *. Before diving into detection techniques, it's essential to understand common vulnerability types. SQL injection occurs when user-supplied input is directly embedded into SQL queries without proper sanitization or parameterization. Attackers can inject malicious SQL code to bypass security measures, access sensitive data, modify data, or even execute arbitrary commands on the database server. Cross-site scripting, XSS involves injecting malicious scripts, usually JavaScript, into websites viewed by other users. These scripts can steal cookies, redirect users to phishing sites, deface websites, or perform other malicious actions within the context of the user's browser. There are three main types. Stored, persistent, XSS*. The malicious script is permanently stored on the target server, example in a database, message board post, or comment section. Reflected, non-persistent, XSS*. The malicious script is reflected off the web server, such as in a search result or error message. It's triggered when a user clicks on a malicious link or submits a form containing the script. DOM-based XSS*. The vulnerability lies in the client-side JavaScript code, which improperly handles user input in the document object model, DOM. The malicious script manipulates the DOM to execute arbitrary code. Cross-site request forgery, CSRF forces a user to perform actions on a web application without their knowledge or consent. An attacker crafts a malicious web page that makes requests to the target web application on behalf of the authenticated user. This can lead to unwanted account changes, unauthorized purchases, or other harmful actions. Injection flaws, command injection, LDAP injection, etc. similar to SQL injection, but targets other interpreters or systems. Command injection allows attackers to execute arbitrary operating system commands on the server by injecting malicious commands into vulnerable input fields. LDAP injection targets LDAP, lightweight directory access protocol, queries, potentially allowing attackers to bypass authentication or access sensitive directory information. Insecure direct object reference, IDOR occurs when an application exposes direct references to internal implementation objects, such as database keys or file names, without proper authorization checks. Attackers can manipulate these references to access unauthorized data or perform actions on objects they shouldn't have access to. Authentication and authorization flaws. Weak or missing authentication mechanisms, such as using default credentials, weak password policies, or not implementing multi-factor authentication, can provide easy access to attackers. Insufficient authorization checks can allow users to access resources or functionalities they shouldn't be able to. Security misconfiguration. Common vulnerabilities arising from improper configuration of servers, applications, or frameworks. Examples include using default settings, exposing sensitive information in error messages, or not properly securing file permissions. Sensitive data exposure. Occurs when sensitive information, such as passwords, credit card numbers, or personal data, is stored, transmitted, or displayed insecurely. This includes storing data in plain text, using weak encryption algorithms, or failing to protect against data breaches. Denial of service, DOS, and distributed denial of service, DDoS attacks that aim to overwhelm a server or network with traffic, making it unavailable to legitimate users. Vulnerable code can be exploited to amplify the impact of a DOS attack. Deserialization vulnerabilities occur when an application deserializes untrusted data without proper validation. Attackers can inject malicious data that, when deserialized, leads to code execution or other harmful actions. Integer overflow / underflow These occur when arithmetic operations result in values exceeding the maximum or falling below the minimum representable values for an integer data type. This can lead to unexpected behavior, buffer overflows, or denial of service conditions. Race conditions occur when the output of a program depends on the unpredictable order or timing of events. This can lead to data corruption, security vulnerabilities, or system crashes. 2. Methods for checking vulnerable code ***. There are several techniques to identify and mitigate code vulnerabilities. 1. Code review, manual. Description *** A manual examination of the source code by experienced developers or security experts to identify potential vulnerabilities. This involves understanding the code's functionality, data flow, and security implications. Advantages can uncover complex vulnerabilities that automated tools might miss. Allows for a deeper understanding of the code's design and security architecture. Can identify logic errors and design flaws. Disadvantages time-consuming and resource-intensive. Requires skilled reviewers with security expertise. Can be subjective and prone to human error. Example reviewing a login function to ensure proper password hashing and salting is used, or checking if all user input is properly sanitized before being used in SQL queries. Code review checklist example, simplified. Input validation. Are all inputs validated, length, format, type? Is input validation performed on the server side? Is there any reliance on client-side validation alone? Authentication / authorization. Are strong password hashing algorithms used, example BCRYPT, Argon 2? Are default credentials changed? Is access control properly enforced? SQL queries. Are parameterized queries or prepared statements used? Is dynamic SQL avoided? Output encoding. Is output encoded to prevent XSS? Is context-aware encoding used, HTML, JavaScript, URL. 2. Static application security testing, SAST. Description SAST tools analyze the source code without executing it. They use pattern matching, data flow analysis, and other techniques to identify potential vulnerabilities based on predefined rules and heuristics. Often integrated into the development pipeline, CI/CD. Advantages can detect vulnerabilities early in the development life cycle. Relatively fast and automated. Provides detailed reports with vulnerability descriptions and code locations. Disadvantages can produce false positives, flagging code as vulnerable when it is not. May miss runtime specific vulnerabilities. Requires configuration and tuning to optimize accuracy. Examples SonarQube, Fortify Static Code Analyzer, Checkmarks, Veracode. Example, Simplified ASAST tool might flag a line of code where user input is directly concatenated into an SQL query string without proper escaping or parameterization. 3. Dynamic Application Security Testing, DAST. Description DAST tools analyze the running application by simulating attacks. They send malicious requests to the application and observe its behavior to identify vulnerabilities, such as SQL injection, XSS, and CSRF. Operates from the outside, like a black box tester. Advantages can find vulnerabilities that are only exposed at runtime. Does not require access to the source code. Can test the application in a realistic environment. Disadvantages cannot identify the exact source code location of the vulnerability. Slower than SAST. Requires a running application to test. Can be disruptive if not configured carefully. Examples OWASP Zap, Burp Suite Professional, Acontix, NetSparker. 4. Software Composition Analysis, SCA. Description SCA tools identify open source components used in a project and check them for known vulnerabilities. They maintain a database of known vulnerabilities, example from the National Vulnerability Database, NVD, and flag components with security issues. Advantages quickly identifies vulnerabilities in third-party libraries and frameworks. Provides information about the severity and impact of vulnerabilities. Suggests updated versions of components to mitigate vulnerabilities. Disadvantages relies on the accuracy and completeness of vulnerability databases. May not identify vulnerabilities in custom or proprietary components. Can produce false positives if vulnerabilities are not applicable to the specific use case. Examples SNYK, Black Duck, White Source. 5. Fuzzing description fuzzing involves providing a program with invalid, unexpected, or random input to identify vulnerabilities or crashes. This can uncover buffer overflows, format string vulnerabilities, and other input validation errors. Advantages can uncover unexpected vulnerabilities that are not easily found by other methods. Relatively automated. Can be used on a wide range of applications and protocols. Disadvantages requires a good understanding of the target application or protocol. Can generate a large amount of data. May not be effective against all types of vulnerabilities. Examples AFL, American Fuzzy Lop, LibFuzzer, Peach Fuzzer. 6. Penetration testing, ethical hacking. Description A simulated attack on a system or network to identify vulnerabilities and assess the effectiveness of security controls. Performed by ethical hackers who use the same techniques as malicious attackers. Advantages provides a realistic assessment of the security posture of the system. Can identify complex vulnerabilities that are not easily found by automated tools. Helps to prioritize remediation efforts. Disadvantages can be expensive. Requires experienced penetration testers. Can be disruptive if not performed carefully. 3. Code examples and vulnerability mitigation techniques ***. Let's look at some code examples with common vulnerabilities and how to fix them. 1. SQL injection ***. Vulnerable code, PHP. Explanation ***. This code directly concatenates user input into the SQL query, making it vulnerable to SQL injection. An attacker can enter malicious SQL code in the username or password parameters to bypass authentication or extract sensitive data. Exploitation example ***. An attacker could use the following URL. Example.com/login.php, username equals or 1 equals 1 and password equals or 1 equals 1. This would result in the following SQL query. Select asterisk from users where username equals or 1 equals 1 and password equals or 1 equals 1. The or 1 equals 1 condition will always be true, allowing the attacker to bypass authentication. Mitigated code, PHP, using prepared statements. Explanation asterisk this code uses prepared statements with parameterized queries. The placeholders are used for the user input, and the miscli_stmt_bind_param function binds the input values to the placeholders. This prevents SQL injection because the database driver automatically escapes the input values, preventing them from being interpreted as SQL code. 2. Cross-site scripting, XSS. Vulnerable code, JavaScript/HTML. Explanation asterisk this code retrieves the username parameter from the URL and directly inserts it into the HTML content without any encoding. This makes it vulnerable to XSS. Exploitation example asterisk. An attacker could use the following URL. Example.com/welcome.html, username equals script alert, XSS/script. This would inject the JavaScript code script alert, XSS/script into the page, which would execute and display an alert box. Mitigated code, JavaScript/HTML, using HTML encoding. Explanation asterisk this code uses the escape HTML function to HTML encode the user input before inserting it into the HTML content. This prevents the browser from interpreting the input as HTML code, effectively mitigating the XSS vulnerability. Using inner HTML after encoding is important. If you were to simply use inner text, as in the vulnerable example, with raw HTML, the browser would not render the HTML, but would display it as text, therefore preventing the XSS in a different, but less controlled way. Using escape HTML and then inner HTML is the proper way to avoid XSS and still allow the display of legitimate HTML characters. 3. Cross-site request forgery, CSRF. Vulnerable code, HTML form. Explanation asterisk this form allows an attacker to craft a malicious web page that automatically submits this form on behalf of the logged-in user. If the user is authenticated, the transfer will be executed without their knowledge. Mitigated code, using CSRF token. Explanation asterisk this code implements a CSRF token to protect against CSRF attacks. A unique, random token is generated for each user session and included in the form as a hidden field. When the form is submitted, the server verifies that the received token matches the expected token. If the tokens do not match, the request is rejected, preventing the CSRF attack. Crucially, HTML special cars is used to escape the token when embedding it in the HTML to prevent XSS. After processing, the CSRF token should be invalidated to prevent reuse. 4. Insecure Direct Object Reference, IDOR. Vulnerable code, PHP. Explanation asterisk this code directly uses the file_ID parameter from the URL to construct the file path without any authorization checks. An attacker can manipulate the file_ID to access unauthorized files. Mitigated code, PHP, with authorization check. Explanation asterisk this code implements several security measures. 1. Input validation asterisk validates that file_ID is a valid integer to prevent path traversal attacks. Type_digit verifies that the input is composed of only digits. 2. Database lookup and parameterized query, simulated retrieves file details, owner, file path, from a database using a parameterized query to prevent SQL injection if the file_ID is used in the database query. 3. Authorization check * verifies that the current user is the owner of the requested file. 4. Path traversal prevention * uses real path to resolve the file path and ensures that it is within the allowed directory /var/www/files/. This prevents attackers from using to navigate outside of the allowed directory and access arbitrary files on the server. Critically, the resolved real path is used with file_get_contents. 4. Best practices for secure coding ****. Input validation * always validate user input to ensure it conforms to the expected format, length, and type. Sanitize or encode input as needed to prevent injection attacks. Use allow lists, positive validation, rather than deny lists, negative validation, whenever possible. Output encoding * encode output before displaying it in a web page or sending it to a client. Use context-aware encoding, example HTML encoding, JavaScript encoding, URL encoding, to prevent XSS vulnerabilities. Least privilege * grant users only the minimum necessary privileges to perform their tasks. Use role-based access control, RBAC, to manage user permissions. Principle of defense in-depth * implement multiple layers of security controls to protect against vulnerabilities. Even if one layer fails, other layers can still provide protection. Regular security updates * keep all software, libraries, and frameworks up to date with the latest security patches. Secure configuration * follow secure configuration guidelines for servers, applications, and frameworks. Disable unnecessary features, change default settings, and implement strong authentication and authorization. Use secure coding practices * adopt secure coding practices such as using parameterized queries, avoiding dynamic SQL, and properly handling errors and exceptions. Security training * provides security training to developers and other staff members to raise awareness of common vulnerabilities and secure coding practices. Regular security testing * perform regular security testing, including code reviews, SAST, DAST, and penetration testing, to identify and mitigate vulnerabilities. Secure development lifecycle SDLC integrate security considerations into every stage of the development lifecycle, from requirements gathering to deployment and maintenance. Tools and resources ***. OWASP, Open Web Application Security Project, a valuable resource for information on web application security vulnerabilities and best practices. Provides tools, documentation, and community support. OWASP.org. SANS Institute * offers training and certifications in cybersecurity, including secure coding practices. SANS.org. NIST, National Institute of Standards and Technology, provides guidelines and standards for cybersecurity, including the National Vulnerability Database, NVD. NIST.gov. CVE, Common Vulnerabilities and Exposures, a dictionary of publicly known information security vulnerabilities and exposures. cve.mitri.org. GitHub security features * GitHub provides various security features, including dependency scanning, vulnerability alerts, and code scanning to identify and address vulnerabilities in your projects. Online courses * platforms like Coursera, Udemy, and Library offer courses on secure coding and application security. 6. Conclusion * Checking for vulnerable code is an ongoing process that requires a combination of manual review, automated tools, and a strong understanding of security principles. By implementing the techniques and best practices outlined in this tutorial, you can significantly improve the security of your applications and protect against potential attacks. Remember that security is not a one-time fix but a continuous effort that needs to be integrated into every stage of the software development life cycle. Staying informed about emerging threats and vulnerabilities is crucial for maintaining a secure and resilient system.